Hello dear students. Today let us learn path lines, streamlines and vertex lines in fluid mechanics. So let us see what are path lines, streamlines and vertex lines. A path line is the path taken by the particle of a continuum during the transformation or motion from initial configuration to current configuration. Okay, see, we have this is the initial at time t equal to 0. Say this is the continuum. This is the continuum. At time t greater than 0, the same continuum has occupied the space here. Okay, any particle here would have moved the path taken by that particle to move from initial to the current. Is nothing but the path line. As simple as that. And the equation of the path line is given by dx by dt is equal to v. V is the velocity vector and x is the point in the current configuration and v is velocity at the point x. Let us see what is streamline. Streamline is a curve in the current configuration. Streamline is the curve in the current configuration such that the tangent at any point on that curve denotes the direction of velocity. And the equation of streamline is given by dx cross v equal to 0. And dx cross v, the cross product is nothing but determinant ijk, the first vector dx1, dx2, dx3, second vector v1, v2, v3. The determinant of that equal to 0. This is also denoted as dx1 by v1 equal to dx2 by v2 equal to dx3 by v3, where v1, v2, v3 are the components of the velocity vector v, dx1, dx2, dx3 are the components of the vector dx. Let us see what are vertex lines. Vertex lines, again, vertex line is nothing but a curve in the current configuration such that the tangent at any point on the curve denotes the direction of verticity at that point. And we all know what is verticity. Verticity is nothing but curl of velocity. And the equation of the vertex line is denoted by dx cross omega equal to 0. This is omega. We know no omega is the denotion of verticity. This is not W here. That has to be omega. And dx cross omega equal to 0, that is the cross product is nothing but determinant ijk, the first vector dx1, dx2, dx3, first vector components, and the verticity components omega 1, omega 2, omega 3, determinant of that equal to 0. This is also denoted by dx1 by omega 1 equal to dx2 by omega 2 equal to dx3 by omega 3. That's the equation of vertex lines. Let us take up some problems now. Problems. Let us take problem 1. Find path lines, streamlines for a motion given by v1 equal to x1 by 1 plus t and v2 is 2x2 by 1 plus t and v3, this is v3 here, equal to 3x3 by 1 plus t. This has to be 3. Okay, now, so they have given the velocity in the spatial form. You have to find the path lines and we have to find the streamlines for this motion. Let us find first the path lines. The equation of the path lines is dx by dt equal to v. Okay, that is dx1 by dt equal to v1 in the components form, dx2 by dt v2 and dx3 by dt v3. Okay, take the first components, consider the first equation. So dx1 by dt is nothing but dou x1 by dou t, xi naught is fixed. We don't know that's a material form, right? Capital D by dt. So what is fixed? Xi naught is fixed equal to v1. That implies dou x1 by dou t equal to x1 by 1 plus t. So separating the variables, we have done this in our previous problems. And dou x1 by x1 equal to dou t by 1 plus t, integrating on both sides, right? And using the initial conditions, the integration constant is also found and we get x1 equal to x1 naught plus 1 plus t, called as equation 1, first path line, the x1 form. Now, similarly, take dx2 by dt equal to v2, okay, on the same lines. That's nothing but dou x2 by dou t xi naught fixed equal to v2 substitution 2x2 by 1 plus t. And separating the variables and integrating, finding the constant using the initial conditions, we get x2 equal to x2 naught into 1 plus t whole square, called as equation 2. Similarly, take the third component, dx3 by dt equal to v3. Same, dou x3 by dou xt, xi naught fixed equal to v3 is 3x3 by 1 plus t. Separating the variables, integrating, and finding the constant using the initial conditions, we get x3 equal to this has to be x3 naught here. This is x3 naught. This is x3 naught into 1 plus t whole cube. So equations 1, 2, 3 are the path lines. They represent the path lines. Only path lines. Now we have to find the streamlines. So what is the equation of streamlines now? dx1 by v1 equal to dx2 by v3 plus equal to dx3 by v3. Okay, now substitute for v1, v2, v3. What is v1, v2, v3? This is v1, v2 and v3. That given, no? We'll substitute that. And all these ratios are equal, we'll take the ratio equal to dt. Fine. So equating the first and the last one. Equating the first ratio to dt. So, and separating the variables, we get dx1 by x1 equal to dt by 1 plus t. So, integrating log x1 equal to log 1 plus t and a constant here k. You can take this k as a function of xi naught also. And log, why we are taken log here? Because we have log and also log here. That is why we are taken this log. Log of k. Instead of k, you can also take any function of xi naught because xi naught is fixed. And x1, equal to k into 1 plus t. And as we all know, using initial conditions when t equal to 0, x1 is x1 naught. So using this, we get k equal to x1 naught. So substituting for k, you get x1 equal to x1 naught into 1 plus t, called as equation 4. Right? So similarly, take the second ratio now. Take the second ratio, that is this, equal to dt. Find x2. Okay, and similarly take the third ratio equal to dt. Find x3. Same steps, right? So similarly we get what? we get x2 equal to x2 naught into 1 plus t whole square, and x3 is equal to x3 naught into 1 plus t whole cube, where 4, 5, 6 are nothing but the streamlines. And check the streamlines and the path lines here, 1, 2, 3, compare them with 4, 5, 6. We know that both the lines are same, coincide. Path lines coincide with each other. That's the problem 1. Now we shall go to problem 2. Problem 2 says that for the motion defined by the velocity field V, they have given 1 plus at a1 plus x1 e2, where a is a constant. Okay, we have to find what? Path lines, and we have to find streamlines, and put a equal to 0 and comment on these lines. We have to find what is happening to these lines when a equal to 0. A is constant. Okay, very simple. Let us take what is given. So given V is 1 plus at E1 plus x1 E2. What is V1? V1 is 1 plus at. V2 is x1 and V3 is 0. So we have to find path lines. The equation of the path lines is dx by dt equal to V. Right. So in components form, we have dxi by dt equal to Vi. No vectors here. There is arrow here. No, this arrow must not be there. This arrow must not be there because we are writing in terms of components. This arrow must not be there. Dxi by dt equal to Vi, I equal to 1, 2, 3, of course. So let us take the first components. So dx1 by dt equal to V1. And what is capital D by dt? That's nothing but the material time derivative. That means what? So x1 by dt, xi naught is fixed, equal to V1. What is V1? We'll put. V1 is 1 plus at. Right? So, separating the variables now. So, separating the variables, we get dou x1 equal to 1 plus at into dou t. Integrating, integration of, this dx1 is x1 and integration of 1 is t. A is constant as it is and t is t square by 2 plus a constant. Constant is taken as a function of f of xi naught. Now we have to find this constant here. We have to find the constant. How do you find this constant here? So when t is equal to 0, x1 is x1 naught. Put t equal to 0 in the above relation and put x1 equal to x1 naught. So x1 is, x1 naught. T is 0. So these two is 0 and that's nothing but f of xi naught. So f of xi naught is x1 naught. Now replace f of xi naught as x1 naught. So therefore x1 will be t plus a t square by 2 into that constant. We just now found that it is x1. Called as equation 1. Okay, now similarly dx2 by dt equal to v2. The second components are same, so considering this, dx2 by dt is nothing but dou x2 by dou t. What is fixed? Xi naught is fixed. This has to be dou here. It is delta. Is appearing delta here. This has to be dou equal to x1. Now separating the variables. So x2 separate and x1. Right. What is our x1? By equation 1, our x1 equation 1 is nothing but you have x1 naught plus t plus a into t square by 2. We will substitute that. This is our x1 into dou t. Remember this has to be dou t. This dou t. So now integrating, we get x2 is equal to x1 naught integration is x1 naught into t respect to t, integration with respect to t on RHS, and t is t square by 2 plus a is constant and t square is t cube by 3 and there is 2 there, so it becomes t cube by 6 and a constant. Constant we are calling it as f of xi naught. So we have to find this constant, integration constant. So when t is 0, when t is 0, so what is our x2? X2 is x2 naught. So using this, so put t equal to 0. So this is gone. This is 0. This part is 0. And this part is also 0. So we get x2 naught equal to f of xi naught. Okay, so now replace that f of xi naught as x2 naught. So we get x2 is equal to f of xi naught is nothing but x2 not substituted. The remaining all these things as is. We'll call it as equation 2. Similarly, consider dx3 by dt equal to v3. Dou x3 by dou t xi naught fixed equal to v3 equal to v3. What is our v3? v3 is 0. So dou x3 equal to 0, cross multiplying. So integrating this, we get x3 equal to f of xi, okay, a constant, f of xi naught, fine. So we have to find this constant. So when t is 0, x3 is equal to x3 naught. So using this, we get x3 naught, that constant f of xi naught is x3 naught. Okay, so therefore, x3 is equal to x3 naught. Equations 1, 2, 3 are the path lines. Now we have to find the streamlines. Now how do you find the streamlines? So what is the equation of the streamlines? This is the equation of the streamlines. So substitute for V1, V2, V3. Okay, so take the first two ratios. So consider the first two ratios are equal. Okay, separate the variables. So x1 part separate, and this x2 has come separately along with t. Now integrate LHS with respect to x1, so x1 square by 2, and integrate RHS with respect to x2. So it is 1 plus at as it is, right, into x2 integration, right, x2 plus a constant is taken as a by 2 here. Because I have 2 here, we have 2 here, no? So we are taking 2 there. Okay, now we have to find that constant. So we have to find the constant. So let us take the initial condition. When t is 0, t is 0, x1 is x1 naught, x2 is x2 naught. So substitute and find the constant a. Constant a is this. Let us call it as 1. Now replace a by this relation. So we get x1 square by 2 equal to x2 into 1 plus at plus that a by 2. Plus that a by 2. Therefore, simplify this. So you're going to get x1 square is equal to 2x2 1 plus at plus x1 naught square minus 2x2. Okay, now consider the other two relations. Equate dx2 by x1 equal to x3 by 0. Equate these two ratios now. Cross multiply. We get x1 dx3 equal to 0. Or dx3 equal to 0. Integrating x3 equal to constant. Okay, how do you find this constant? Using the initial condition. When t is 0, x3 is x3 naught. Therefore, we get that constant a is x3 naught. So put that here. Get x3 is equal to x3 naught. That's our 1 and 2 are nothing but the streamlines. Now we have to comment on these lines when a equal to 0. Put a equal to 0 in the path lines. What are the path lines? Where are the path lines? So we found the path lines. So path lines are 1, 2, 3. Path lines are 1, 2, 3. So here I have 1. This is, equation 1. So in this equation, I have to put a equal to 0. Okay. And in equation 2, put a equal to 0. And in equation 3, there is no a here to put equal to 0. So the path lines will put a equal to 0. Path lines, when you put equal to 0, a equal to 0, you get, equation 1, equation 2, and equation. And in the streamlines, what are the streamlines? Streamlines, we have got this. The streamlines. What are the streamlines? Where are the streamlines? So our streamlines are, yeah. So equations, this one square is our, you the streamlines. In this streamlines, again put a equal to 0. Right, that's one of the lines, and you have one more line here. So that is this. So put a equal to, anyway, there is no a there. So put a equal to 0 in the streamlines also. So when you put a equal to 0, the streamlines we get 4 and 5. 4 and 5. Okay, 4 and 5. These are the streamlines. Now, just watching these two, path lines and streamlines, we see that there is T appearing in the path lines and there is no T in the streamlines. So we'll eliminate T now. So what is equation 1? Equation 1 is this. Right, in the equation 1, what is T equal to? T is nothing but x1 minus x1 naught. So eliminating T now. So T is nothing but x1 minus x1 naught. So put T equal to x1 minus x1 naught in equation 2. In equation 2. Okay, and simplify that. Simplify and we'll get like this. Okay, when you simplify that equation, we get this. So the path lines after eliminating T are nothing but these two. They are nothing but same as streamlines. Same as streamlines. We observe that the path lines, after elimination of T are nothing but same as streamlines. So they coincide when the constant A is 0. That is the observation we made. Okay, guys, and this completes 2 problems. Okay, thank you.